Hello everyone, welcome back. In this video, we are going to continue our conversation about using factoring to find the zeros of polynomial. In the previous video, we checked the method about using GCF and AM method together to figure out the solution. In this video, we are going to check another two different examples. Let's check. The first one, as you can see, we have two terms instead of using three terms. And still, we need to find 0, so I'm going to set up equation as equal to 0. Next, so we are going to try the different method, but I will suggest you always give it a try for GCF to see if you have greatest common factor. For this two, as you can see, the coefficient was 2 and negative 18. They're both even number, so I'm going to take 2 out of this, and x is third, x, I'm going to take x out of this. Next, we just need to figure out what to put inside. As we mentioned before, you can always use reverse process of distributive property, or you can use division to use all the term divided by 2x to figure out what's put inside, and you probably have the answer here. Okay, so next we are going to look for the possible ways to factor x squared minus 9. So side notes to remind you, if you do remember, we mentioned in the previous lesson in quadratic function, when we have two, one square, the other one is perfect square number, we can use difference of perfect square, which I'm going to break down a negative 9 as 3 and negative 3 to factor this. So next, I'm going to write down difference of perfect square. So now equation become 2x, I just copied it down, and next part become x plus 3, x minus 3. By the way, the key word here is difference because this will work when it is minus 9, and you can also use FOIL to double check if this is working. As you can see here, you will look at plus 3x, minus 3x, and minus 9. So that's why this one are canceled. So that's why difference of perfect square is working. Okay, so now let's go back to check the solution. So as you can see, we have three parts multiplied to get 0. So we are looking at three possible equations, then three possible solutions, 0, negative 3, or 3. Okay, so again, this time we use GCF combined with difference of perfect square. So as you can see, we can use multiple methods. Really depends on what kind of situation we need to deal with. Okay, next example. This time we have two terms here, but a little bit different from the last one because this one we have variables. One is variable, the other one doesn't have. And one has coefficient as 1, the other one is just constant term 16. So really nothing for us to take out. So GCF definitely not going to work. Let's just set up equation first. But another thing I want to remind you, if you observe or pay attention to the structure of these two terms here, you will notice 16 is perfect square and 4 is like square times square. So we can use a kind of a extended form of difference of perfect square. So we focus on the difference of perfect square, but kind of using a different format. So I'm going to break down x to the fourth as x squared. And since it's subtracting 16, I'm going to use difference of perfect square to set up as the two parts. And so this is like a format of difference of perfect square. So it's not exactly the same of difference of perfect square, but as you can see, we actually use the idea of this two. So next, I'm going to check if there's anything more for me to do. First, I'm going to check this one. 4 is also perfect square, so I'm going to set up this one as plus 2 minus 2. Some students might say, oh, I can do the same thing for the plus 4 too, because but the answer is no, because as we mentioned, this is working because we have minus 4, and using FOIL, you can check the two terms, 2x and minus 2x is cancelled. But for this one, it's not working. Some students might say, can I try x plus 2 times x plus 2? It's also not working. Let's check. X times x is x squared, this is 2x, and this is 2x, and this is 4. Apparently, this is now canceled, right? So this is still there, so that's why they're not equivalent. So how do we do with that? This time I'm going to use the special number we had before, which is called I. So I'm going to break down as 2i and minus 2i. Why? Because negative 2i times 2i is negative 4 times I squared, which is negative 4 times negative 1. So that's why it's 4. So that's why we break down, actually I break down 4 as 2i and minus 2i. So now we are looking at 4 factors, which means I'm going to have 4 possible solutions. So let's set up all equations as 0, and then we are having 4 solutions, negative 2i, 2i, negative 2, or 2. That's it. By the way, I use or because x cannot be the same different number at the same time, so you cannot use and, but or. So x can be this or this or that. So 4 possible solutions. So very special thing, huh? In this one, we do not use GCF. Instead, we use a format of difference of perfect square to help us break down a original polynomial as 4 parts and a very special solution including I, imaginary number. Okay, so that's all the example I want to share with you for this type of factoring. Of course, factoring is always combine different ones. So in the very soon, you are going to check another video. There's also going to be another example for us to see what's the other way to factor. See you soon, everyone.